Hi, welcome back to another class of Advanced Artificial Intelligence. This is Tarik Rashid. Today I'm going to talk about LSTM. This is the first part, theoretical part, and we have another three parts about practical of this algorithm or this machine learning technique. So LSTM, it is a shortcut for long short-term memory, which is a special type of recurrent neural network, RNN, designed to learn and remember information over long sequences of data. So this type of machine learning can be used for um, time series application, where where time is very relevant. Now, it is mainly used for time series sequential and language-related problems. LSTM solve the vanishing gradient problem found in normal recurrent neural networks. Um, LSTM actually was invented by Sepp and Jorgen in 1997. The main idea of LSTM is an LSTM cell contains a memory state and three gates that control information flow. These three gates are very, very important. One of them is called forgate gate. Forgate gate, it's the gate that decides what information to ignore or to remove. Uh, Input gate decides what new information to store. So input gate decides what new information to store, and output gate decide what information to output. So this allows LSTM to keep important long-term information. So what information to remove, what information to store, and what information to output. Um, so basic mathematical model for each gate. So this is for four gate. It's sigma equation or sigma formula. Weight of four gate, weight matrix for gate weight, and previous hidden with input plus the bias for gate forget gate. Sorry. Uh, Input gate, again, sigmoid function, weight matrix for input, again, previous hidden, uh, uh, concatenated with input pattern plus the bias for input. Now, cell state update can be done by this format. So for gate, multiply by state previous plus input multiplied by state or current. Now, output gate can be decided by the output of the hidden, which is the output from the forgate gate multiplied by uh, tangent function of cell memory. CT is the cell memory now. So input for the current input pattern and hidden cell memory sigmoid function, and this is element-wise multiplication. So if you have a matrix, so each element multiplied by the other element. So this is the sign for element-wise multiplication. So element-wise multiplication. So this is the element-wise multiplication. Now, advantages of uh, LSTM, long-term dependencies, handles sequential time series data, reduces vanishing gradient problem, effective for natural language processing and speech tasks, can remember useful past information. That's also important. Disadvantages, computationally is expensive, this machine, slower training than uh, simple RNN, because simple RNN kind of doesn't have all these gates. So it doesn't have for gate gates, input gates, memory cells, and output as well. So it only has input to the output. Requires large data sets, complex architecture, may overfit on small data sets. So you need to have a greater data sets so that you can train this network. Now, applications where this algorithm, this machine learning can be used is natural language processing, machine translation, speech recognition, text generalization, sentiment analysis, stock market prediction, weather forecasting, handwritten recognition, healthcare, and other applications in medicine and engineering as well. So this is more or less about the theoretical part of LSTM. Stay tuned for the other three parts for machine learning on a practical part on this LSTM.